A very good evening, good afternoon, whenever you are watching this lecture. So, in the last lecture, you have seen कि SN2 will be, just now I have dictated you, sorry, कि SN2 will be, just now dictated na in this part, कि SN2 will be 1 degree, then 2 degree, then 3 degree, electron withdrawing group, dictated na here, SN1. SN2 will be, here I have dictated here, electron withdrawing group, then 1 degree, then 2 degree, then 3 degree, and SN1 is opposite to that. Opposite means first electron donating group, then 3 degree, then 2 degree, then 1 degree. Those who have seen the last lecture of first part of hydrocarbon, they will understood what I am trying to say. Suppose in this part, this is P, this is Q. They are asking which one of the following will do SN2 faster. So this is 1 degree, this is 2 degree. 1 degree will do faster than 2 degree. Over here, this is 2 degree, this is, because after removing BR we have to check na. Over here after removing BR we have to check. So this is 2 degree, this is 3 degree. This is P, this is Q. Which one will do faster? P will be faster than Q. Over here, after removing, this is 1 degree and this is also 1 degree. But here the branching is little bit further. Here branching is little bit nearer, and branching is not good for SN2. It is good for SN1. So in this part, which one is good? Q is greater than P. No, sorry, P is greater than Q, because branching is not good. The P is greater than Q. Understanding or not? If you're not understanding, means you have not seen the first lecture. Now over here, they are asking in this part, remove it, it will become 1 degree. Remove it, it will become 2 degree. P, Q, which one is faster? P is greater than Q. SN2 asking. Here 1 degree, here 1 degree. Everything is same. No branching, nothing is there. But leaving group, I is better leaving group than Cl. Leaving group, I is better. So if it is P, it is Q. Which one is good? P is greater than Q for SN2 mechanism. Understood? Similarly, they are asking for SN1. Remove this, plus here. Remove this, plus here. This is 3 degree, this is 2 degree. This is P, this is Q. So P is greater than Q because SN1 is opposite to SN2. Understood the point? Here it is 2 degree. Here it is 1 degree. So P and Q, SN1. So P will be greater than Q because 2 degree is more than 1 degree. So I hope you understood each and everything about SN1 and SN2, what I am trying to dictate from here. From here I have started the second lecture. First lecture you have already seen, I hope so. So please try, if you have not seen, please try to see it. On that basis I have done some questions. Now we are going to see the next part of this topic, that is application of SN mechanism. It means in hydrocarbon I have dictated you E1 very properly and E2 very properly. In haloalkanes and haloarenes I am dictated you SN1 very properly and SN2 very properly. Understanding na? So I am saying those who are seeing organic chemistry, please see each and everything from beginning. Understood? Now we have application of nucleophilic substitution. This application is for both SN1 as well as SN2. Sir, I am saying one thing. First of all, in the beginning, those who have reached up to this in the video, it's a request. I am making the each and everything about organic chemistry. Please try to see from the beginning. Acha. We are going to see application of SN mechanism. Before writing application, first try to understand some trapper are there. Trapped means silver will trap halogen, phosphorus will trap oxygen, sulfur will trap oxygen, Zn will trap oxygen. Trap means they will not allow them to go outside. Silver does not want the halogen will go outside. Phosphorus does not want oxygen. Sulfur does not want oxygen. As well as zinc also does not want oxygen to go outside. Then whenever you are doing the reaction with silver, So what you will get here I am writing, whenever you will do the this is not the application. Before writing application I am dictating you something. Suppose you will do the reaction with silver. So it may be you will get AgCl, you will get AgBr, you will get AgI. The color of AgCl is white precipitate. The color of AgBr is pale yellow precipitate. And the color of AgY is yellow precipitate. Understood this part? Ha sir, understood. Now we are going to start the application. In that application I have taken Rx over here, alkyl halide, and that Rx I am going to react line by line, and this reaction is very important. Some flow chart I am writing. Those who will understand this flow chart, for them reaction will be very easy. AgF, second one KCN, third one AgCN, fourth one KNO2, fifth one AgNO2, sixth one moist Ag2O, seventh one dry Ag2O. Now when you will react alkyl halide with AgF, it will give RF, alkyl fluoride, plus AgX, and we know that this reaction is known as Schwarz reaction. Schwarz reaction, and in Schwarz reaction we will use the reagent as AgF, Hg2F2, COF2 and SbF3. Second one, when you will react with KCN, it will break as K plus Cn minus, and it will become RCN. When you will react with AgCN, it will not break as Ag plus Cn minus. Why? Because copper, Ag and gold all have pseudo noble gas configuration. What is pseudo noble gas configuration, sir? Pseudo noble gas configuration means, suppose you will get copper 29. I have already dictated in some basic concept of chemistry topic, but do it. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. But we are saying that this is wrong. We have to write 4s1, 3d10, and this is known as pseudo noble gas configuration. And covalent character is directly proportional to pseudo noble gas configuration. More is the covalent character, more covalent bond. So Ag, copper and gold has covalent character, so it will not break like an iron, so it will attack from the lone pair side of N, and it will form RNC. Similarly, it will break as KNO2 structure is something like that. KNO2 structure first draw, N double bond O, O, K. It will break as minus plus, ions form. So what it will happen? It will form RONO. RONO. It will attack from O minus side to RONO. But again, Ag has noble gas configuration, so it will not break. It will attack from N side to RNO2. Moist Ag2O will give OH, and it will become ROH. But dry Ag2O will react with 2 moles of alkyl halide, and it will give ether. So this part you have to see. This is, I have dictated something like a flow chart. Something like a flow chart. So over here we will have all these things, that is application of SN1, not SN1, nucleophilic substitution reaction. This part definitely everyone will see. Direct reaction is coming. Now something is given in your NCERT book. Up to this visible? Sir, visible. something is given in the NCERT book, we have to see what they are trying to dictate. Very important part. Acha sir. Over here, if you will see, they are saying that we have a reagent and we have to react that reagent with Rx. With whom I have to react? Rx. This will go and R will attack. Over here, OH minus is there. It will do SN2. Over here, H2O is there. It will do SN1. Over here, OR minus. Over here, I minus. Over here, NH2. Over here, RNH2. Over here, RRH. Over here, Cn minus. Over here, AgCN. Like that. What is forming over here? ROH. It is ROH. Both will go. ROR. RI. It will attack lone pair. RNH2. RNH 2 degrees there. So 2 degree form. 3 degrees there. So like that they have written some reaction of product. Means what are product coming? Name is also written. Product is coming like that something. Means I am trying to say this part. That over here we have OH minus and RX. It will form ROH. Over here H2O will give RH, ROH. But SN1, SN2. Over here RO minus react with RX. It will give ROR. Over here I minus react with RI. NH2 will react. It will form RNH2. Over here 2 degree is there. This is 2 degree type. So what you will get? RNHR. Similarly, over here 3 degree is there. So what you will get? N is there. So what you will get? RNR. Over here Cn minus to RCN. But Ag has pseudo-noble gas configuration to RNC. Like that I am writing some bottom. Over here KNO2 to attack from oxygen negative to RONO. But AgNO2 attack from lone pair of nitrogen RNO2. RCOO minus to RCOOR. And over here RR will give R and R dash. Once you will see this flow chart, what I am trying to dictate, I hope you understood it. Just see once. It is given in NCERT also. Haloalkanes and Haloarenes page. Haloalkanes and Haloarenes page. Check that note, book in NCERT book. They have given this. Once you will check, any doubt, you can see it once again and try to understood. So I hope up to now you have understood this flow chart. See how many things you have to remind. First this flow chart. Then after that, this all reactions once you have to see what is going to be happen inside the particle of this reaction. Understood? Everyone? Ha sir, understood. Now we are going to start next part of the topic, that is called halogen exchange. Next topic is halogen exchange, and I am saying don't get panic. If you have reached up to this, it means you are properly watching my video. 9267937718 is my calling and WhatsApp number. Don't call, just message. If you have any doubt, I will try to clear your doubt. Understood na? See each and everything very properly. Something you have to learn, something you have to understand, and slowly you are able to get each and everything. But one request and one suggestion, don't come over here for haloalkanes haloarenes. Line by line, if you have to see organic chemistry, see from the beginning. Isomerism, GOC, hydrocarbon, everything. If you are coming for haloalkanes haloarenes, no problem. But basic things you have to be aware with. Okay sir, understood this. Now we will have the next part of the topic, that is called halogen exchange. In this halogen exchange, already you have seen one reaction. Halogen exchange has two reactions. One is Schwarz reaction and one is Finkel-Steen reaction. Which reaction? Finkel-Steen reaction. The Schwarz you have already seen over here, AgF type. Now we are going to see the second halogen exchange, that is called Finkel-Steen reaction. In Finkel-Steen reaction, we will tell Rx. X will be chlorine or bromine. React with sodium iodide in presence of dry acetone. It will give Ri plus NaX. If you will see, it is covalent bond. It is also covalent compound. Covalent compound, like dissolve like, so it is soluble, but it is ionic. So this is insoluble, and as it is insoluble, so it will make precipitate. Understanding? So it is a precipitate. Why precipitate? Because covalent soluble, so it will react and form Ri, but NaX is ionic, insoluble, so it will not formed. So first we have seen each and everything. When I have started, in the beginning I have written कि first I will dictate you reaction of haloalkanes completed. Now we are going to see method of preparation of haloalkanes, then reaction of haloarenes, and method of preparation of haloarenes. Very small topic, don't worry, because hydrocarbon I have already covered too much. So over there lots of things I have already covered. Now we are going to see the next part of the topic, that is called method of preparation of haloalkanes. Method of preparation of haloalkanes. And if I am teaching little bit slow, you can see that in YouTube 1.5x there is an option. And sir, don't get bored, trust me. You will see my sound is not coming clearly. Still I am doing the hard work, because I know if you will study properly, you will get IIT JEE. Content is important. Quality is also there. I don't want to come here and do jokes and make you happy. Over here, I am trying to give you a serious teaching. And serious teaching will only give you the JEE result. On YouTube, you didn't have to come to do jokes. Understood, na? If you want, I will do jokes, shairi, all these things. But first, complete the syllabus. Joke shairi will be the last part. The method of preparation of haloalkanes from alcohol. ROH I have taken. I will react alcohol with HX, or I will react alcohol with PX3 in presence of red phosphorus and X2. I will react alcohol with PX5, or I will react alcohol with SOX2. Every reaction I will give detailing also. But first write reactions. It will give alkyl halide. It will also give alkyl halide. It will also give alkyl halide. It will also give alkyl halide. Any problem? Now, what will happen basically that they are giving alkyl halide in each and everything. So see over here. What happen? Ki whenever you will do reaction with alcohol, means first I have written one reaction, so you will understood what I am trying to dictate. Over here, whenever you will do reaction with alcohol, reaction with alcohol. So what happened? Ki first of all, alcohol is there, ROH is there, and we have some HX. HX will break as plus minus like this, and plus will attack on the lone pair of alcohol. Once it will attack on the lone pair of alcohol, lone pair of oxygen, not alcohol, ROH, one more H will come. Oxygen getting positive charge. As it is getting positive charge, what it will do? It will try to remove this water from here. The water will go outside. After the water will go outside, what you will get? R plus. R plus you will get. Achha. Once you will get R plus, X minus is coming over here. That X minus is coming over here, and they will react, and after reacting, they will form RX. Means, suppose I will go with example, not X, 1, 2, 3, 4, OH, and I am reacting this with HCl and a little bit heat. What will happen? First of all, over here, you will get something, H plus Cl minus, H will attack, 1, 2, 3, over here, OH and H, water will go from here. After going water, what you will get? Ringa, chinga, pinga, over here plus, on this plus, Cl minus will attack, and you will get the product, not this. First, carbocation formed, so do rearrangement, Rearrangement means hydrogen from here going, plus will come, already dictated in hydrocarbon, plus will come here, and Cl minus will attack, the product is coming Cl over here. Understanding what I am trying to dictate? Ha sir, it means from here, if I want, I will write some important point. Reaction of alcohol. What? First of all, there is a formation of carbocation. If carbocation formed, then rearrangement may occur. If there is a possibility of rearrangement, you can do rearrangement also. After that, you will write the electron donating group, because carbocation is formed in SN1, and SN1 is very happy with electron donating group. SN2 is very happy with electron withdrawing group. So electron donating group will increase the rate. So I hope you are able to understand what is happening in reaction with alcohol with HX. Some important point you will write about HX. HX will be HCl, HBr, HI. So write some important points. Suppose they have given HI in presence of HX in the same alcohol. So over here, no condition required. No condition required. Only you have to take care. You will take NaI or in presence of H3PO4. Don't try to take NaI in presence of H2SO4. NaI in presence of H2SO4. Otherwise, I will not react and it will form I2. It will form I2. So in case of HI, we are not using H2SO4. We are using H3PO4. First condition. Sometimes they will ask the question also. Ki H2SO4, why we are not using it? So H2SO4 will not use because H2SO4 will form I2 in presence of reacting with alkyl halide. Means if you will react ROH with HI and you have used acetone in presence of H2SO4, reaction will OH will not come, carbocation coming and I2 coming. I will not react over here. So more will happen. So don't use H2SO4. This is the first situation for HI. Then if HBr is there, over here no condition, only H2SO4 you didn't have to use. You have to use H3PO4. Over here condition is there. Whenever you are using HBr, you have to use slight constant heat. Little bit slightly constant heat you have to provide, as well as you can use NABr in presence of H2SO4 or H3PO4, H3PO2, no problem. Either you will use H3PO2 or H3PO4, but slight heat is required, as well as nothing is required. NABr, H2SO4, anything you will use. These are the condition. Understood na? In place of HI, H2SO4 can't be used. In place of HBr, slight constant heat will be used. This is the different part. Whenever you are using HCl, you have to do heating, as well as you have to use little bit dry HCl or some Lewis acid. Why Lewis acid? Ki HCl is there, some Lewis acid AlCl3, it will form H plus and AlCl4 plus, sorry, minus. So the conditions are ki HI don't use H2SO4, remaining heat is not required. HBr you can use anything, H2SO4, H3PO4, but constant heat is required. Over here heating to important, as well as HCl will be dry, or if not dry, then use some Lewis acid. Now I hope everyone has understood this first important point of reaction of alcohol with alkyl halide. Acha. Now over here, if you use HCl in presence of ZnCl2, or you will take concentrated HCl only, so no required of ZnCl2, or you will take N, or not like that you will write, in different way you will write. Either you will take HCl and ZnCl2, or you can use HCl plus heat, or you can use directly HCl also. If alcohol will be 1 degree or 2 degree, then you will use this or this. But if alcohol is 3 degree, simple you can use this. Understood? But condition is that because you are reacting HCl with alcohol, na? So alcohol will be 1 degree or 2 degree, you can use this. 3 degree directly you can use. Condition is that ki HCl will be concentrated HCl and ZnCl2 will be anhydrous ZnCl2. Anhydrous ZnCl2. And the name of this reagent HCl plus ZnCl2 is known as Lucas reagent. The name of this reagent is Lucas reagent. Suppose you have taken alcohol and that alcohol will be 3 degree alcohol. So what happened? 3 degree chlorine will come, alkyl halide. If you have 2 degree alcohol, so what happened? 2 degree chloride will come, halide will come. If you have 1 degree alcohol, then 1 degree chloride will come. If 3 degree alcohol is there, it will follow SN1 rearrangement. If 2 degree alcohol is there, SN1. But if 1 degree alcohol, 1 degree coming, so SN2 it will form. This will give immediate turbidity or white PPT. White PPT or turbidity. Over here, SN1 will take 5 to 10 minutes to give white precipitate or turbidity. And over here, no turbidity at room temperature. Understood? Lucas reagent? Ha, sir. And this Lucas reagent, this process, this whole process of HCl in presence of ZnCl2 plus alcohol, this whole process is known as Group's process. GROOVES, Group's process. The alcohol part, I hope lots of things I have dictated. Once again you will see the alcohol part with HX very properly. Alcohol part I have dictated up to now with HX only. PX3, PX5, SOX2 not dictated. HX is this one. कि carbocation forming, SN1 coming, electron donating group will increase. HI has no condition, don't use H2SO4. HBI has slight heat and HCl has heating and dry HCl plus Lewis acid or Lewis acid. HCl plus ZnCl2 you will take. ZnCl2 is a Lewis acid. Same part I am dictating of HCl. Only in the case of HCl, 3 degree will give SN1 and white precipitate immediately. It will give 5 to 10 minutes, no turbidity. And this all process of Lucas reagent is known as Group's process. GROOVES, PROCES, Group's processes. Now, question is there. Which of the following will give alcohol reaction, Lucas reagent? Which of the following will give? What you will say? First option. First question 1, 2, 3 OH. Second B part Ringa Chinga OH. C part Ringa Chinga Pinga Hinga OH. D part PH CH OH CH3. E part Ringa Chinga Pinga Hinga Linga OH. F part Ringa Chinga Pinga OH. G part Ringa Chinga Pinga Hinga Linga OH. H part Ringa Chinga Pinga Hinga Ringa Bhatinga OH. Now they are asking which of the following will react with alcohol and doing turbidity easily. Turbidity. Turbidity. So over here, sir, it will give, yes, 3 degree. It will, sir, 1 degree. Not possible. Sir, it will, sir, 2 degree, sir. 2 degree will give turbidity. Sir. So 1 will give, 2 will give. It will, sir. Yes, sir. It will also give turbidity because resonance is stabilized. Sir, this one, no, sir, partial double bond, moe. This one, sir, yes, sir, it will give turbidity. Over here, this one, sir, yes, sir, it will give, why? Dancing resonance. I have dictated you dancing resonance in GOC. Yes, sir, it will give. No, sir, Britt's rule. Not allow the sp2 hybridization on bridge carbon. So not possible. How many of them will give? 1, 2, 3 and 4 and 5 will give the white precipitate. I hope you understood the part very properly. Anyone has any doubt regarding this? Acha, if they will change the question and they will ask this will give turbidity. If they will ask immediately turbidity, then what you will say? Sir, this 3 degree immediately, this 2 degree muhe, this to resonance stabilize, 1 degree muhe, this phenyl to not happens, this yes, yani 1 will be less, so immediate turbidity will be given by 4 compound, but turbidity will be given by 5 compound. 1 compound 2 degree will give turbidity, C part after 2 to 4 minutes. So I hope you understood what I am trying to dictate. The first reaction in detailing I have dictated you about Rx with Hx. Now we are going to see the second part, that is Px3 in presence of red phosphorus and Br2. Red phosphorus and X2. I hope everyone has understood what I am trying to dictate up to now. Yes sir, we understood it. Okay, then come to the next part of the topic, that is this one. This I will try as much as possible complete. If all completed, then I will be very happy. If it will take time, then I will do one more, but most probably I will try. Guarantee I can't give, but I will try. Okay sir. Now next part is the reaction detailing I am doing, understanding na? That you will see one time more. Reaction with red phosphorus in presence of X2. What happens when red phosphorus in presence of X2 will react? Over here you have to take 3 mole of alcohol that will react with red phosphorus in presence of suppose Br2, or this red phosphorus and Br2 will be written as PBr3 also. Don't get confused. So you will get 3 mole of RBr plus H3PO3. Their byproduct is also very important. Sometimes they will ask what is the byproduct when red phosphorus react with Br2, that is PBr3. So H3PO3 is the byproduct. First important point, it will follow SN2 mechanism. First one is following SN1. This whole alcohol reaction is follow SN1 mechanism. Over here this reaction with alcohol will follow SN1 mechanism. Reaction with alcohol will follow SN1, but red phosphorus X2, that is PBr3, will follow SN2 mechanism. Second important point, if SN2 will be there, then inversion will be there. If inversion will be there, then electron withdrawing group will increases the rate, not electron donating group. Over here suppose ringa, chinga, pinga, and here on the ways OH will be there, and they will react with PCl3. What is the product coming? You will say, sir, inversion. So ways will convert into dash. Understanding something. Haan sir. So this also done. Red phosphorus X2 done. Now we are going to see next one, that is reaction with PCl5. PX5 written na? Over there PCl5 will be there. What will happen in the PCl5? Something like this. What happens, sir? ROH is there. They will react with PCl5 and it will give RCl plus HCl plus POCl3. Here also this byproduct is very important. Sometimes they are asking in the exam. Over here I will give you the trick to understood what is happening over here. You will take alcohol like this, ROH, and over here PCl, Cl, Cl, Cl. 1, 2, 3, 4, 5 Cl. What happened? From here, this Cl will go to H and this Cl will go to R. This Cl will go to R. So it will go to H, it will go to R. It means this will also, from back side it will go, So this will also follow SN2 mechanism. This will also follow SN2 mechanism, as well as this will also do inversion. Understood the point? It means backside product is coming. That is done. Reaction with PCl5 also done. SN2 written means you understood it. Next part of the topic, that is reaction with SOCl2. I've now understood this part. Over here I have not mentioned, but you have to understood that this X, what are the things I have taken? I have taken I, Br and Cl. F I have not taken. Over here X I have taken what? Br and Cl. F not taken and I not taken. Over here X I have taken only chlorine, bromine not taken, iodine not taken and fluorine not taken. Over here X I have taken only chlorine, bromine not taken, iodine not taken and fluorine not taken. So that you will take care. I am writing only those that is possible. Don't get confused. Okay sir, okay sir, okay sir, okay sir, understood. Reaction with SOCl2, and this reaction has a particular name like that. First reaction HX has Lucas reagent and process is Group's process. Similarly, this reaction name is Darjan process. This reaction name is Darjan process. What will happen in the Darjan process? ROH is there. They will react with SOCl2, S double bond O, Cl and Cl. Their name is thionyl chloride. Their name is thionyl chloride. It will react and it will form RCl plus SCl plus SO2. We know that SCl is a gas and SO2 a gas. So we get a gaseous product. Gaseous product. And as the gaseous product coming, so this reaction will give best yield to alkyl halide. From all the previous one, it will give best yield to alkyl halide. What is happening inside it? See it very properly. ROH is there plus S double bond O, Cl and Cl is there. What happened? This Cl is going outside and this oxygen lone pair is attacking here. Cl going to plus coming, oxygen attacking. After attacking of oxygen, what is the things coming? Next page I am writing. It will become R, oxygen attacking, hydrogen is present, S, double bond O, Cl. Ab now Cl minus is outside. Ab now this oxygen getting positive charge, this oxygen will also remove and this plus and minus will react and it will form RO, S, double bond O, Cl plus HCl. This coming, after coming to this, what it will do? It will make the structure something like this. R, over here, this will break little bit S, over here S, and it is breaking some bond is coming over here double bond O, over here Cl is little bit breaking and attacking over here. Something happen like this. Understood? So this is forming what? 4-member ring. 1, 2, 3, 4-membered ring. This you have to understood how the mechanism is happened. So it will form 4-member chelate rings. This is called 4-membered chelate ring. It will form 4-member chelate ring. After that RCl will come. This Cl will go here and this total will go outside. So what is going outside? SO2. SCl has already go outside as a gaseous product. SO2 going from here. So you will say कि over here, if you will see what is happening, everything happen inside. So it is known as internal nucleophile. And whenever internal nucleophile is there, it will follow SNi, intramolecular nucleophilic substitution, and intra will do retention, not inversion. So first HX will do SN1, that is retention, inversion both. Red phosphorus plus X2, that is PX3 will do inversion only because SN2. Then PCl5 will do inversion only, but this will do retention because of SNi. I. Understood the point? Everyone? हाँ sir. So I have written lots of SN1, SN2, E1, E2, nucleophilic substitution SN1, SN2, SNi, SN1 prime. So in that I have completed SNi. It is something like that. And in Darjan's method only we will see. So you didn't have to learn all the mechanism. You have to know it will do retention product. But if you will take over here HCl plus pyridine, this is the structure of pyridine. So what will happen? It will form the compound something like this. Over here nitrogen, and this will take hydrogen, plus will come here, and outside Cl minus, and this Cl minus will act as a nucleophile. Means you will write simple point. Prabhat sir, Prabhat Jans logic. If simply they will write SOCl2, then you will say it will do SNi. But in case of pyridine or NET3, NET3 means 3 degree amine, either pyridine or NET3 ethyl will be there, then SOCl2 plus pyridine or SOCl2 plus NET3 ethyl, this will do takes place, this will do SN2 mechanism. SN2 mechanism, that will do inversion product, that will form inversion product. Means if Darjan's method only with SOCl2, then it will do retention product as SNi mechanism. But if you will use SOCl2 plus pyridine or SOCl2 plus NET3, so Darjan's method is there, name is same, but it will follow SN2 mechanism and it will do inversion product. Suppose I have written one example over here to make the topic clear. CH3, CH2, CH3, HOH. I am reacting with PCl3. I am reacting with PCl5. I am reacting with SOCl2. I am reacting with SOCl2 plus pyridine. Now tell me what is the product coming. You will say, sir, in this case it will follow SN2. So inversion is there. So you will get CH3, CH2, CH3. Over here H and this side Cl. Over here it is also SN2. So CH3, CH2, CH3. Over here H and Cl. And both will follow SN2. So inversion coming. Understood? Cl is here. Now for this SOCl2, it will do SNi. So Me, matlab CH3 means Me. Over here ET, CH2, CH3, ET. Over here H, Cl will attack on the same side. Why? Because it will follow SNi, intramolecular. But again with pyridine, what will happen? Me, ET. And over here H, Cl is attacking on opposite side, because this time it will follow SN2 mechanism. So SN2 mechanism means opposite side. SNi or SN1 means same side. I hope everyone understood what I am trying to do, the bakwas over here regarding this. Suppose I will take one question over here. They have written some NRBr is there. Means not like that. NRBr don't write. You will get confused. Suppose over here RBr is there. That will first react with NaOH. Then second react with PCl3. Then third react with NaI in presence of acetone. Then fourth react with NaOH. Then fifth react with SOCl2 in presence of pyridine. And product is coming something like that. Kabhi. And over here. Cl is coming. Now tell me what is R. what is R. So just listen this part very properly. Directly I will write the answer of this question. Suppose I have two options. This part to not changing. So I will say, sir, I will take the R will be two options. This part to as it is. Over here nothing happen. Either I will take Cl here or this part as it is, or I will take Cl here. My choice. R as R. Over here I will take Cl. Now I am going to react this with each and every reagent. I will react with NaOH, 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 NaOH with 2 degree. It will do SN2. So what happened? This dash will convert it into beige. Sorry, beige. So over here, ringa chinga pinga. One second. Yes. Now I am going to write each and every reaction. This will do SN2. In electrophilic aromatic substitution, last part I have dictated this. 2 degrees there, polar protic solvent, it will do SN2, 3 degree SN1 like that. Over here, it will do SN2. Finkelstein will also do SN2. It will also do SN2. It will also do SN2. All will do SN2 only. Achha sir, like that. No, first check. This part you can't say SN1 or SN2. NaOH. SN2, no problem. NaOH first now also. Means what happened? First, see it very properly. First, I am not going to draw all. First, NaOH will react. Cl will convert it into OH by dash to base. After that, PCl3, OH will convert into Cl, base to dash. Then NaI, again, base will convert it into dash Cl. Any problem? I will take this example. Now NaOH, again OH will come and dash base will convert it into dash. Then again SOCl2, dash will convert it into base. Means I am doing from here NaOH to base dash base OH. Then PCl3, again SN2, base dash. Then NaI, again dash base. Again see, don't get confused. Again all will do SN2. NaOH, I am first reagent, NaOH. So OH will come with SN2. So dash will convert to base. Achha, okay sir. Then again PCl3 will give Cl, but SN2. So base will convert to dash. Okay sir. NaI, I over here, not Cl. By mistake I have written. I over here. Now in this I, what you will say? Sir, over here, NaI. NaI will also do SN2. I will give. So dash is converted to base with I. Then NaOH, again do SN2. It will do OH. Again I have written Cl. So I also get confused. OH will come, but base will convert it to dash. Then again SOCl2 pyridine, SN2 dash. This is the answer now only. So this is the correct. If you will try over here, first NaOH converted base to dash OH. Then PCl3 base Cl, then dash I, then NaOH, base OH, then SOCl2, dash Cl, but in the product, Cl is on the base. So this is the answer, this is not the answer. You understood how I am doing it? SN2 everyone is na, so I am changing base to dash, dash to base, base to dash, dash to base. If SN2 is not there, SNi is there, then I will not change it. Understood? Everyone? Any confusion? No sir, we understood it. Okay sir. I know that you are a very talented and most talented person of my life, so you will not found any difficulty over here. Sir, we didn't find it. Now, some more example I will take. Suppose some other example. This completed now. Haloalkanes done. Haloalkanes method of preparation done, sir. Now we will say, sir, over here in the NCERT book given by free radical mechanism, given by alkene, that you have to not dictated, hydrocarbon completed, na sir. So why I will dictate again? Those who have watched hydrocarbon, they understood it. Something I am not dictating that is given in your NCERT, because that part I have already dictated in hydrocarbon. One question. Cl2 in presence of H mu, what will happen? Ringa, chinga, pinga. This only given in hydrocarbon. One example I will take. Suppose ringa, chinga, pinga, H X. It will follow Markovnikov's. More hydrogen will get hydrogen, less will get X. Detailing I have done. Over here, Ringa, Chinga, Pinga and Br2. What will happen? Vis di bromo will coming. Br and Br. Like that you have seen in hydrocarbon. More example I am not going to take. So first I have dictated you first lecture SN1, SN2. Second lecture I have dictated you the preparation of method of preparation of haloalkanes. Now I am going to dictate you SN1 prime and SN2 prime. What is SN1 prime? SN1 prime. This it is prime. After 1 I have written 1 dash means prime. And this will come only whenever we have resonance product. What do you mean by that? Just wait and see. Over here, suppose I have given Ringa, Chinga, Pinga, Batinga, Latinga, over here Jhartinga, OH and this. You will react this with HBr. What will happen? Sir, we will get one product. How many product we will get? See it over here. First, H plus will attack over here. After attacking H plus, what will happen? Ringa, Chinga, over here you will get plus, over here you will get double bond. After getting double bond, you have a possibility that on this plus only, you will attack Br. So Ringa, Chinga, Pinga, Ringa, Tinga, over here Br. Or you will do resonance. Pi sigma positive. After doing resonance, you will get something like that. Double bond here, here and plus is coming here. Any problem? Now you will attack Br over here. Over here you will attack Br. So this product is known as SN1 prime. Means after carbocation, whenever you are doing resonance and that resonance product is known as SN1 prime. So this product is known as SN1 prime. This product is known as SN1 prime. This product is known as carbocation simple SN1 mechanism. But this product is known as SN1 prime. Don't get confused. Over here double bond is there. I have not changed it. Understood? So resonance product is SN1 prime. Similarly, SN2 prime is also a resonance product. SN2 prime is also a resonance product. Suppose I have taken like this Cl here. What will happen? Cl will in presence of NaOH. Cl will go. Now, one option you will do over here OH directly. Another option you will do resonance. And after doing resonance, double bond is coming here, OH is coming here. So resonance product you have drawn, it is known as SN2 prime. It means after drawing resonance, if you are giving the any, this one is SN2 prime. So after drawing that means any place, if you are doing resonance and after that something will attack, that product is known as SN1 prime and SN2 prime. Understood this part? हाँ sir. So haloalkanes 100% completed. Now we are going to see haloarenes. Not a bigger topic. Don't worry. Very less part. Maximum half an hour I will complete the remaining thing. Then done. Haloarenes. Not that a big part. Because haloarenes I have already dictated. Electrophilic, aromatic, substitution. Over there 90% things I have completed regarding haloarenes. 10% left I will complete here. Understood the point? Yes sir. If any confusion, see it once again and tell me. Now after haloalkanes, we are proceeding to the next part of the topic, that is called haloarenes. So I am suggesting you all guys and boys and girls, please watch the lecture of, which lecture sir? Hydrocarbon. Most hydrocarbon, electrophilic aromatic substitution and Grignard reagent. Most of the things I have completed over there. And what I have completed there, I am missing that topic in the haloalkanes alcohol. I will not do that. Over here we will do their reaction and we will do their method of preparation. Method of preparation will follow SN1 aromatic. Dictated lots of mechanism, and reaction will follow. Reaction will follow SN2 aromatic and electrophilic aromatic substitution. Remember na? Sir. And SNEA. But this is not in our syllabus, so I will not teach that. So this topic and this topic, this haloarenes will be also compulsory. So now see over here. First, what I will do? First, I will take aniline. I will take aniline NH2 and I will react that aniline with NaNO2 plus HCl at 0 to 5 degrees Celsius, that is low temperature. In presence of NaNO2 plus HCl, sometime they will write also HNO2. So don't get confused. They will give this. This will convert this into benzene diazonium salt N2 plus Cl minus. This is known as BDC. BDC means sir benzene diazonium salt. Then benzene diazonium salt will do like this. Over here cation coming and N2 will come. It means benzene diazonium salt is directly proportional to electron donating group because plus is coming, and inversely proportional to electron withdrawing group. And donating group, withdrawing group, I have already dictated lots of time regarding this. Okay sir. Now see some reaction I am going to take. First I have make benzene diazonium salt. After making benzene diazonium salt, I will write over here benzene diazonium salt N2 plus Cl minus. This benzene diazonium salt react with Ki. This benzene diazonium salt react with Cu in presence of HCl. This benzene diazonium salt react with Cu in presence of HBr. This benzene diazonium salt here on the bottom will react with Cu2Cl2 in presence of HCl. This benzene diazonium salt react with Cu2Br2 in presence of HBr. This benzene diazonium salt react with HbF4 in presence of heat. First reagent HbF4, second reagent heat. What will happen? See over here. With Ki, it will give benzene diazonium salt. Can I write pH? This can be also written as pH N2 plus Cl minus. So pH I will come. Over here pH Cl will come, pH Br will come. The name of this reaction is Gattermann reaction. Over here pH Br will come. Over here pH Cl will come. This name reaction is Sand-Meyer reaction. Over here pH F will come, and the name of this reaction is Boltzmann reaction. And understood, fluorobenzene can be formed by only two parts, one Schwarz reaction, one Boltzmann reaction, and all this reaction will follow SN1 aromatic. This all will follow SN1 aromatic. So SN1 aromatic also done. Understanding la? So remaining SN1, SN2, everything is very smaller. Now after this we are going to see the next part, and that part is called bimolecular aromatic substitution. Bimolecular aromatic substitution. What is that? So I am suggesting, sir, if you want to study organic chemistry with me, trust me, I will not let your trust down. I will give you as much as best as possible from my side. But each and everything you will see, not one part, two part like that. Now, and I have given one sort of hydrocarbon also, and this one sort also I will give. Over here X react with NaOH. You will say, nah, nucleophilic substitution to not possible, aromatic substitution. So over here no reaction. But you will take aryl halide and react with NaOH at 623 Kelvin and 300 atm, then it will react and form phenol. It will react and form phenol. And this process of reaction with high temperature, high pressure is known as Dawes process. Which process is known as Dawes process? Understood? Everyone, Acha, what is happening in this part? Dawes process, C1's mechanism. Over here you have aryl halide, one double bond, one double bond, one double bond. Over here X is there. OH minus will come. This OH minus will break this part over here na. X little bit more electronegative, so it will get del minus, little bit del plus will come, minus will come over here. Once it will take electron only, not going outside. Once the minus will come, what will happen? Or don't do it like that, some different way. Don't get confused. One second. Going. Not like this. Understood in different way. Over here, double bond will break as a minus and plus. This is correct. By mistake, I have written that. Over here, what will happen? X will be here, and this OH minus is attacking in this place. Over here, minus will come here. This minus will do resonance. Again, what you will get? You will get ringa, chinga, pinga, hinga. Over here X not OH. Over here X. Again what happened? X is there, OH is there. Double bond coming here, minus is coming here. Again it will do resonance here. Double bond will go here. Here double bond, here minus. X is there, OH is there. If you will draw the resonating hybrid structure, what you will get? Sir, ringa, chinga, pinga. Double bond coming here. Up to this double bond is coming. Now up to this the double bond is coming. Over here X. Over here OH. And minus sign is rotating every place. Whenever the plus sign is rotating, that is known as electrophilic aromatic substitution. That is known as carbocation. It is known as carbonian ion. Carbonian ion. Carbonian ion. Or it is known as meta complex. Previously I have written sigma complex plus charge. It is meta complex. It is anion. Anion is coming on where? Sir, ortho position, para position, ortho position. So it is coming on ortho and para position, as well as rate is directly proportional to a stability of anion. Stability of anion means rate is directly proportional to electron withdrawing group, inversely proportional to electron donating group. Understood this part? Acha sir, we understood. Now over here you have to understood one more part, that over here if they will ask, sir, in place of X you can take na fluorine, chlorine, bromine, iodine. So in which case rate will be more? So rate of reaction, if ARF is there, it will be more than ARCl, then ARBr, then ARI. What is the reason behind it? The reason is due to minus I effect of X. Chlorine, bromine, iodine, which has more minus I effect, they will show more rate of reaction of carbonium ion. Next. Why? Because electron withdrawing group required. Na? How much minus I will be there? Carbonium ion is that much stable. So it is there. Next. Rate of reaction. Suppose you have taken over here X, and in that X you have attached NO2. But over here you have taken X and you have attached 2 NO2. Over here you have taken X and you have attached 3 plus NO2. NO2 is a electron withdrawing group. How much electron withdrawing group you will attach, that much easily the reaction will happen. So it will give very easily, it will give easily. Over here, whenever you are only using X, you need 623 and 300 atm. But whenever you will add 90 degree NO2 group, temperature reduced to 443 Kelvin. Over here, temperature reduced to 638 Kelvin. Over here, you can do the reaction with warm water only. Understood the point? So this is all about bimolecular nucleophilic substitution reaction. Now I am going to write some questions to understood what I am trying to dictate. जैसे first question. First question I have something like that. कभी 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 over here Cl, this is benzene ring, over here NO2, over here NO2, and they are saying react with NO2 NH2. What happened? They have a lone pair of electron. Cl will go, NH2 will come here. What you will get? Ringa, chinga, pinga, here, 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 over here, NH2, NH2, over here, NO2, over here, NO2. Temperature you can write 368 Kelvin. 368 Kelvin temperature. I am not writing because I have already written. Acha. Suppose I will take another one. Ringa, chinga, pinga, hinga, Cl over here and NO2 over here, and I am reacting with PH SNa. It will break as plus and minus, but NO2 is attached on meta position, and meta position no minus M, no minus R, only minus I will be there. So it will not attack, it will not react that much, so no reaction. It needed on ortho and para position. Understanding the point? हाँ sir, understanding. Third question. Suppose I have taken ringa, chinga, pinga, over here Cl, over here Cl, over here NO2. Now I am reacting with NaOH. Which it will react? With chlorine it will react. So this chlorine is on meta according to NO2, but this chlorine is on para position. So they will not touch the chlorine on meta position. This will touch the chlorine on para position, and OH will attach on para position. Understanding the point? हाँ sir, understanding what you are trying to say. Suppose I have taken fourth example. Over here CH2 Cl, over here F, over here NO2, and over here NO2, and I have taken PHS Na. Over here it is minus, it is plus, salt na. Now see what will happen. If you will check from this side CH2Cl, it is not aromatic compound, resonance stabilized, it will do SN2. But if you will check from this side, it is fluorobenzene, it will do SN2Ar, aromaticity will do. So what will happen? Over here benzene ring is coming, NO2 will be as it is, NO2 will be as it is. This place S, pH will attach, but this place CH2 S, pH will attach. But bottom side is S, bimolecular aromatic substitution, and top side is written a heading written here, bimolecular aromatic substitution means SN2Ar. So over here bottom side on the benzene ring directly attached, so it will do SN2. On the top side benzene ring not directly attached, so it will do SN2 directly, but over here SN2Ar. So this is all about method of preparation of aryl halide and reaction of aryl halide. Remaining electrophilic aromatic substitution and hydrocarbon, I have covered all the part, don't worry. Now next part we have to see the physical properties. First physical properties, that boiling point is directly proportional to molecular weight. Boiling point is directly proportional to hydrogen bonding. Boiling point is inversely proportional to branching. And for boiling point, you already know lots of things. Suppose I have given one question. Ringa, chinga, pinga, Cl. Ringa, chinga, pinga, Cl. Ringa, chinga, pinga, Cl. Now tell me. So you will say over here 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Yani A, B, C. Mole of molecular weight in C. Then over here we have no branching. Over here we have branching. Over here we have branching, inversely proportional. Then A, then B. Boiling point understood? Everyone. Especially you will learn the boiling point of hydride of group 15, group 16 and group 17. Very important. Group 15, New Zealand, Pakistan, Australia, सब बीमार. Group 16, O, C, T-Po don't write because radioactive. Group 17, Fatak, Khol, Bahar, I, Anti means stentine don't write. It is radioactive. Hydride means NH3, PH3, ASH3, SBH3, BIS3. H2O, H2S, H2SC, H2TE. HF, HCl, HBr, HI. Now, for group 15, over here, these three is forming hydrogen bond. And hydrogen bond topic also I have uploaded. Confusion C. Over here you will write कि BiH3 will be more. Then SBH3. In the middle, NH3 will come. Then ASH3. Then PH3. Acha. For group number 16, H2O is hydrogen bond. They have more molecular weight. So first write H2O. Then go from bottom. H2TE, H2SC, H2S. Means hydrogen bond I have written first, then more molecular weight. Similarly, over here hydrogen bond in the middle. That you have to remember. Over here HF has more boiling point. Then go with atomic weight. HI, HBr, HCl. So first you have gone with hydrogen bond. After that molecular weight. Now next part of the topic we have to know is the melting point. Melting point is packing efficiency. How much packed is there the compound? That much is the boiling point. And packing efficiency means symmetrical type. Over here, suppose I have given one question. Trans alkene and cis alkene. Second question. Ringa, chinga, pinga, hinga, linga. Cl here, Cl here. And over here, Cl here, Cl here. Third question. Ringa, chinga, pinga, hinga, linga. Cl here, Cl here, Cl here, Cl here. And ringa, chinga, pinga. Cl here, Cl here, Cl here, and Cl here. Now C over here. Over here, it is packed from this side and this side. Total packed. It is packed from this side only. Bottom side, no packing. It means in cis and trans. Right, very important. Boiling point of cis is more than trans, but melting point of trans is more than cis. This part you have to learn every time. Over here, this will be packed from these two sides, but this will be packed totally from here. So melting point, I am talking about only melting point. Which has more melting point? This one. Over here it is packed from here, here, here and here, but it is packed from here, both side combined, this side combined. So this has more melting point, means this melting point is more. Over here melting point of this will be more, and over here melting point of trans will be more. Why? Because it has more packing. So I hope you understood about melting point also. Then last part of the topic, simple SN1 graph. Directly learn. Ringa, chinga, pinga. Graph will be something like this. First will be bigger one, second will be a smaller one. This is the graph for SN1. Just learn it. Don't worry about it. SN1 graph. In free radical I have dictated you na. Free radical first hydrocarbon first lecture ki free radical graph will be simply like this. So SN1 graph will be simply like this. And this is all about the completion of the chapter called hydrocarbon. And sorry, haloalkanes and haloarenes. And I hope everyone has enjoyed what I am trying to dictate. If anything coming very slow, you can increase the 1.5x, 1.25x, or if anything coming very fast, you can reduce it. If any doubt, you can ask. I have already given you my number. So I hope you understood it, and don't compare with NCERT. This topic not done, this topic not done. Whatever with the topic I have not teaches over there, that I have completed in hydrocarbon. So my favorite topic is hydrocarbon, Grignard reagent and electrophilic aromatic substitution. And these three videos are present on my channel on one shot. You will see it, and then you will come for haloalkanes. You will enjoy this chapter. Okay then, bye. Have a nice evening. Enjoy. Take care. Stay home. Stay safe.